looking into the different types of nephrons, we have one that's referred to as a cortical nephron. Now, this is the vast majority of all nephrons. I have down here it's 85%. Well, that's a range. I mean, again, this can be a little lower, a little higher. Each person's a little bit on the unique side. But regardless, that's the majority of them. These cortical nephrons are limited only to the cortex of the kidneys. So they're staying up in the cortex, and that's where all their functionality is. Now, in contrast, the juxtamedullary nephrons, these juxtamedullary nephrons actually dive deep down into the medulla. They're going to have loops of Henle that are going very far down into the actual medulla and the pyramid. They function this way because they're helping deal with the concentration of urine, which we have to even talk about that. So that's something coming up in the future. But they have extensive thin segments as they're going deeper and deeper and deeper into the medulla. So cortical nephrons and juxtamedullary nephrons. So from this image, you can see that we have one of each. We have the cortical nephron, which is over here. And yes, you can see the loop of Henle goes a little bit into the medulla, but not very much. In contrast, the juxtamedullary goes way down, much, much deeper. So let's look at the individual parts and pieces. You'll notice that the actual nephrons here, all the tubing is a lot more mixed up than we've seen in the past. This is more indicative of what realistically would look like. Again, you only have two here, but there would be a whole series all around the collecting tubes. So first off is that renal corpuscle again. Remember, the renal corpuscle is the glomeralis, the capillary, and the glomerular capsule around it. Both together are the renal corpuscle. From there, you go to the proximal convoluted tubule. That's what accepts the filtrate from the renal corpuscle. You'll notice that in this case, those curves are all mixed in with the capillaries and the other tubing. From there, we go to the loop of Henle, go down the descending loop and back up the ascending loop of Henle to the distal convoluted tubule. That distal convoluted tubule is going to dump into the collecting duct. You'll notice there's a lot of pieces here of the collecting duct that are not attached. All of those, each one, will connect to another nephron. So you can get an idea of how many of these things are all packed around each individual collecting duct. Now for the blood vessels again, make sure you're keeping the same idea here. You notice the arcuate artery. Remember, the arcuate artery, which is the red one right there, sets the boundary of the cortex above it and the medulla below it. So that's how you can see and know that the cortical nephron is just a little bit going into the medulla in this case. From there, we go to the cortical radiate artery. Remember, the cortical radiate artery then goes into the afferent arteriole. Afferent arteriole connects to the glomeralis. Glomeralis is what's inside that renal corpuscle, remember. The glomeralis is where the filtrate is occurring. It's leaving the blood, going into the nephron. From there, with the efferent arteriole coming out. Efferent arteriole goes to the peritubular capillaries, which are in the cortex, or the vasa recta, which are in the medulla. So either one of those depends on the type of nephron that you're attached to. You then have the cortical radiate vein. Cortical radiate vein goes back to the arcuate vein and continues its pathway after that. So looking at that glomeralis again, we mentioned the glomeralis is where filtration occurs. That's where the blood is being filtered out into the nephron. What's interesting is blood pressure is higher here than most capillaries. Now, it's not high like the aorta high, but it's higher than other capillaries. The reason it's higher than other capillaries is because the afferent arteriole is larger than the efferent arteriole. So think about a pipe coming in that's this large and the output's only that large. It doesn't fit. So it creates a pressurized system inside of that glomerulus. And it's that pressure that allows the filtration to occur. It's forcing the filtrate out of the blood, all those different components. The ions, the particles, the debris, the whatever. All that's being pushed out through the glomerulus into the nephron. And then the blood leaves via the efferent or exit, efferent arteriole. Remember that arterioles are high resistance vessels. The whole point is to change pressure. So afferent arteriole in is one size, efferent is a different size out, smaller, which creates a pressurized glomerulus. Now, in contrast, the peritubular capillaries are low pressure. They're not meant to be pushing things out into the nephron. Their main goal is dealing with absorption. They're trying to bring things that leave the nephron back into the blood. So that's the peritubular capillaries. The vasa recta is also a low pressure capillary system. Just like the peritubular, it's not trying to push things out, it's trying to collect and pick things up. Its main function is dealing with concentration of urine. I want to talk about that later on, but keep in mind, these very long, deep loops of Henle that go down into the medulla that have these vasa recta are dealing with concentration of urine. So again, we're looking at peritubular capillaries are up here in the cortex. Vasa recta is down here in the medulla. And both of them have their own distinct functionalities. While the cortical nephrons are the majority of the nephrons, and that's dealing with most ions and components, those vasa recta are specialized in dealing with the concentration of urine, and therefore water and salt levels. So a little about the nephrons themselves, and a little more about the functionality of the different components.